Greetings. This is the Unit 4 review. Some great practice questions to get ready for the Unit 4 test. Please write your name and number at the top so that you can get credit for your work. Even if you're not doing this review maybe at home, or maybe you don't have the sheet with you, this is a great opportunity to see how the questions will be worded so that you can determine whether you are familiar with these or whether you need a little bit more practice. So let's dig in. Lacey needs to arrive at her work by 7:45 a.m., but she needs 30 minutes to drive there, 20 minutes to cook and eat breakfast, and 45 minutes to shower and get ready. When should she wake up to get to work on time? So this is when she needs to arrive. And then she has all of these things to do before then. So what time does she need to wake up? I highly encourage a number line. They are extremely helpful. So that's what I'm going to draw right now. Okay, so here's my number line. This is when she needs to get to work. We said 7:45 a.m. Okay, and then we have all of these things. We have to go back in time. 30 minutes, 20 minutes, and 45 minutes. Whoo! Wow. Well, I do see a pretty friendly number here because this is when she needs to get to work. There's a 45 in there. And we know she needs 45 minutes to shower and get ready. So what if I jump back 45 minutes, and what time would it be? Well, then it would be 7 o'clock. Now I have to deal with a 30 and a 20. So what if I go back, well, there's a couple ways I could do it. I could add 30 plus 20 and go back 50, or I could go back one at a time. I'd say go back 30 minutes, and then we'll say go back 20 minutes. Okay, subtract half an hour from 7 a.m. and we would have 6:30 a.m. And then if I back up 20 more minutes, it should be what? 6:10 a.m. That is when I am going to need to wake up. And you're going to notice, since this is a review, regularly I'll turn you loose and I'll have you finish problems without me or do some independently. Since this is a review, I am going to go through every question, and hopefully that makes you comfy cozy with this test coming up. Brianna ran a mile in 10 minutes and 17 seconds, but Haley ran a mile in 14 minutes 24 seconds. Who ran faster? By how much? Well, to know who ran faster would be the person who finished sooner, the first person to finish. Well, this was 10 minutes and 17 seconds. Haley, 14 minutes and 24 seconds. Who took less time? Brianna did. Okay? But by how much? That, once again, I would highly suggest a number line to help us with this problem. So I draw my number line. I'm going to mark maybe the faster time here, the slower time here. We said that Brianna was faster, 10 minutes, 17 seconds. And I'm just going to use M and S just a pinch. 10 minutes, 17 seconds, and then for Haley, that was 14 minutes, 24 seconds. Okay? So, personally, I would highly suggest you try to get to the next minute. So how do I get from 10 minutes and 17 seconds to 11 minutes? Well, I need to take 60 minus 17, and I get 43, right? Here's the tricky part on this problem, is that I'm going to go up 43 seconds. So make sure you label it 43s. Okay? And then what if I wanted to come back to to 14 minutes? Okay, I am at 14:24. I'm going to go back so that I'm at an even 14 minutes. I'm going to remove what? 24 seconds. Make sure you label it, because here's where it gets a little tricky. How do I get from 11? Oops, that's not a great line there. How do I get from 11 to 14? Or 14 to 11? Well, I can either add 3 or subtract 3, right? So the difference here is 3 minutes. Now if I look at all of the time in between here, this is where I have to be very specific. I have 3 minutes, I have 43 seconds, I have 24 seconds. If I add up these seconds here, 43 plus 24, and I like to just use the algorithm so I know I'm correct. 4, 5, 6, 7, 4, 5, 6, 67 seconds. Well, that is more than a minute, right? A minute is 60 seconds. So this is 1 minute and 7 seconds. All right? Now I can combine it to get the total time overall. So I need to do my 3 minutes plus my 43 and 24 seconds, and I'll have my answer. 3 plus 1 is 4, so my answer is 4 minutes, 7 seconds. All right, we're talking about John running a race. He ran a 2K, a 3K, and a 24K. K doesn't stand for kilometers, it stands for thousand, right? So this is like a 2,000 meter race, a 13,000 meter race, and a 24,000 meter race. I need to know this information because it says how many meters did he run. And if you're unsure, the best thing that you could do, K equals 1,000, and then all you need to do is add 3 zeros to all of these numbers, which is what I did. 2 becomes 2,000, 13 becomes 13,000, 24 becomes 24,000. Then I can stack them. And then add. The nice part is all of these zeros add up to be zeros. Then I can focus on these 3 numbers here. 4 plus 3, 7, plus 2 is 9, 2 plus 1 is 3. Am I done? No, 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 no. Don't forget your units. And then you're done. Okay? Mrs. O'Callahan drank 1,100 milliliters of water before school, 500 milliliters at school, and 3 liters after school. So how many milliliters did she drink in all? Well, I have 1,100 milliliters. I also have 500 milliliters, and then I have this naughty number right here. And we know that 1 liter is 1,000 milliliters. So 3 liters, if 1 is 1,000, 3 will be 3,000. So I have to convert that before I add them together. They are pretty friendly though when you do have them all converted. The zeros add down to a 0. The zeros add down to a 0. 1 plus 5 plus 0 is 6. 3 plus 1 is 4. So as I look at this, I have to make sure that I have all milliliters in order to be able to add them. If I accidentally just add a 3 to it, I'm going to have an inaccurate answer. The race wants to give each runner 200 grams of oranges. They can buy 6 kilogram boxes of oranges. Fill in the ratio table for grams and kilograms. Use the information to figure out how many 200 gram servings they can get out of 1 kilogram box of oranges. Well, this is just a ratio table. 1 kilogram is 1,000 grams. Looks like we're just going to fill this in number order. 1, 2, 3, 4, 5, 6. And then make sure all of these kilograms get converted to grams by adding 3 zeros, because there is 1,000 grams in 1 kilogram. And if you need to at any point stop this video so that you can catch up or rewind so that you can make sure you're not confused, then please do. So there's part of my problem. I have a little bit more here. They can get blank 200 gram servings out of 1 6 kilogram box. So think of it this way. I have a box. Ooh, you're going to see whether I can draw in 3D or not. So they have a 6 kilogram box of oranges, and they want to know how many 200 gram servings can they get out of here. Well, kilograms and grams don't match, so I'm going to convert this box of oranges into grams by either using my ratio table or adding 3 zeros, because we said that 6 kilograms is the same as 6,000 grams. Okay, so how many 200s fit in 6,000? Technically, that's a division problem. I could take 6,000 divided by 200 to get my answer. I could also set up a ratio table, and I'm sort of gonna do all of them, okay? If I set up a t-chart over here on the side, I could do 1 serving is, what did we say? 200. Okay, it would be helpful if I wrote that down correctly. 1 serving is 200. So in other words, you can think of 1 person will get 200 grams of oranges, which means 2 people would get 400 grams of oranges. 3 people would get 600 grams of oranges. 4 people would get 800 grams of oranges, and 5 would get 1,000 grams of oranges. Now, you could keep going and do this over and over and over again until you get to 6,000. That could take a little while. So rather than just adding 1 and adding 200, why don't we take this last number that we just wrote and convert it into 5,000? To turn 1,000 into 5,000, I'm going to take it times 5. 1,000 times 5 is 5,000. And then, if I did it on one side, I have to do it on the other. 5 times 5 is 25. So now I'm at 5,000. Oh, and I'm realizing we're trying to get to 6,000. Oh, my brain is broken. Okay, so let's do this differently. Or not. Well, yeah. So if we're at 5,000 and we want to add another 1,000, then I need to add another 5, which would give me 30 and 6,000. Sorry, I really should have just taken it times 6, but for some reason I thought we were trying to get 5,000, but we're trying to get to 6,000. So I took a little bit longer than I could have, and that's okay, but I wish I would have maybe gone from 1,000 straight to 6,000 by taking it times 6. So my answer would be 30. Now, if you want to do the division, you could, but notice this. When you're multiplying and dividing and you have lots of zeros working with, you can eliminate all the zeros in the smaller number and that many zeros in the other number. So 200 loses 2 zeros, 6,000 loses 2 zeros, and then I'm left with 60 divided by 2. Well, what's half of 60? 30. Exact same answer. So we're going to get 30 servings, or we'll be able to serve 30 people who are in this race. True false time. We've got grams and kilograms, seconds and minutes, liters and milliliters, centimeters and meters, and we know a few things. For example, one liter is 1,000 milliliters. Let's see, 1 kilometer is 1,000 meters. We know that 1 kilogram is 1,000 grams. We know 1 minute is the same as 60 seconds. We know that 1 meter has 100 centimeters. These are all things that we've looked at in our unit and in previous units. 2 kilograms should be what? Add 3 zeros. Should be 2,000 grams. So that is false. 60 seconds in 1 minute? True. We know that. Are there 100 centimeters in a meter? Yes, there are. And then let's see. 1 milliliter is 1 liter. Well, I thought this said that 1 liter was 1,000 milliliters, so that one is false. Kind of a long one here, but it's worth knowing. If you're not sure how to say some of these numbers sometimes, I like to cover up the last bit and then say the word 1,000 when I see the comma. So let me zoom in just a little bit so we can work on this. So what number is that? 123. 1,456. So if you're worried about how to say it, you can cover up the last half and say the word 1,000 when you get to the comma. So 123, 100, 23, and then what did we say the comma was? 1,000. And then what is this number? 456. 456. Now, if we were going to break this down into our expanded form, I guess I need to zoom out in order to do this. Looks like we're going to start with 100,000s. How many of them are there? There's 100,000. How many 10,000s are there? Looks like there's 2 10,000s. So that's 20,000. Looks like there are 3 thousands. How many hundreds are there? It looks like there are 4 hundreds. There are 5 tens and 6 ones. Remember, if any of these numbers are zeros, it would be like writing a 0 where you would normally put the number, which is why oftentimes they just leave them out. If that 5 was a 0, they would put no tens in there. Okay? 987,465. So if you want to, you could cover up everything to the word thousand and just write that number. 987. So I'm going to do that right now. 987. 1,000 is our comma, and you'll notice I even write one in for you. And then you can write the rest. 465. 465. As you go into expanded form, from left to right, we're going to do 100,000s, 10,000s, thousands, hundreds, tens, ones. So how many 100,000s? I have 900,000. How many 10,000s do I have? I have 8 10,000s. How many thousands do I have? I have 7 thousands. How many hundreds? I have 4 hundreds. I have how many tens? I have 6 tens. And I have 5 ones. Then I'm going to go backwards. Here I have 100,000, 10,000, 1,000, 100, tens, and ones. So I have all the numbers. I'm not missing anything. And you can double check by going, there's no zeros, 1 0, 2 zeros, 3 zeros, 4 zeros, 5 zeros. That's a good way to check to see if you're going to have any zeros in your number anywhere. So let's just write these orders in down, looking at all of the initial digits. Okay? So it looks like I have an 8, a 5, a 3, a 9, a 6, and a 4. I'm going to put my comma after the thousands. And now I can write that down. Cover it up and say the number. 853. 853. What does the comma represent? 1,000. And you can put a comma in your word form. 964. 964. Takes a while to do it, but as long as you're methodical, then you will probably make very few mistakes. We're going to round to the nearest 100,000 or 10,000 using the same number. If I round to the nearest 100, well then I'm going to end with 2 zeros. If I round to the nearest 1,000, I'll have 3 zeros at the end of my number. And if I round to the nearest 10,000, I'm going to have 4 zeros at the end of my number. Okay? So rounding to the nearest 100, right? So this is either going to be 900 or 1,000. I have to decide whether I'm going to round up or down. In order to know if this is going to be 1,000, round up or down, I look at the digit before. So if I'm rounding to the hundreds, I'm going to look at the tens. If that is a 4 or less, I round down. If it is a 5 or higher, I round up. This is a 4 or lower, so this is going to round down so that this 36 turns into nothing. So I'll have 327,900. So I rounded down to the nearest 100. Now when I look at thousands, this is either going to round up to 8,000, because if you ignore this, it looks like 7,936. It's either going to round up to 8,000 or down to 7,000. To know what that's going to be, I look at the previous digit next to the 7, and I say 4 or lower rounds down, 5 or higher rounds up. Well, that's a 9, so we know that's going to round up to 8,000. So I should have 328,000. Finally, if I'm looking at the 10,000s place, right, I'm trying to figure out whether this is going to be 320,000 or 330,000. I need to know if it's going to round up or down. To do that, once again, I look at the digit next to it on the right side and I say 4 or lower, round down, 5 or higher, round up. That's a 7. It is a 5 or higher. So that's going to round up, making this 330,000. If you're going to use the standard algorithm to solve these, that's fine. Some of these, though, you could be a little sneaky in how you solve them by using give and take, which we could talk about if you wanted to. So here we go. 498 plus 327. I can zoom in so you can see my carrying pretty well. 8 plus 7 is 15, carry the 1. 9 plus 1 is 10. 10 plus 2 is 12, carry the 1. 4 plus 1 is 5, plus 3 is 8. I am done. Now, could I have done some give and take? Absolutely, I could have added 2 to this number and subtracted 2 to that number. 500 plus 325. It's pretty easy to add that. 5, 2, 8. Same answer. Maybe even a little faster. Same thing here, is we can do standard algorithm. 7 plus 5 is 12. Carry the 1. 5 plus 0 plus 1 is 6. 3 plus 1 is 4. 3 plus 2 is 5. 6 plus 2 is 8. Standard algorithm is pretty fast on that one. As I move into subtraction, this is where you have some choices to make. And I'm going to show you how maybe some give or take would make this problem so much easier. For example, if I did maybe give, I could make this 8,900 if I just simply add 1 and then add 1. So it's got to be give, right? So this would be 8,900. Guess I better put some equal signs in here. And this would be 20,701. Now when I go to subtract, how does that going to look? 1 minus 0 is 1. 0 minus 0 is 0. I can't borrow, or I can't subtract 7 minus 9, but I can go next door and borrow a 1 by boxing the 20, taking 1 away, which is 19. And then I've got a really nice setup. 17 minus 9 is 8. 19 minus 8, or excuse me, 9 minus 8 is 1. 1 minus nothing is 1. So I end up with 11,801. If I was going to do that without doing the give, what you would find is that the problem gets a little bit muddier. So, and I do just briefly want to show you this. 20,700. 8,899. I'm going to write it out so that I can space the numbers just a little bit more. Can't subtract 9 from 0, so I'm going to go next door and borrow from this 70. That's why I put a box around it. When I take a 1 away, it's going to turn the 70 into 69. That's good, right? 10 minus 9 is 1. 9 minus 9 is 0. 6 minus 8. Darn, I can't do that. So once again, I'm going to have to go next door and borrow from this 20. When I borrow a 1, this becomes a 16, and this 20 becomes a 19. 16 minus 8 is 8. 9 minus 8 is 1. 1 minus nothing is 1. I get the exact same answer, but I end up having to box 2 numbers, which allows for maybe a few more mistakes, versus our problem here where we only had to box 1 time. I'm not saying you have to do it one way or the other, but just keep it in mind. If you see a number that's pretty close to maybe 1,000 or 100, well then consider making that number a little bit more friendly for you. One more subtraction. 8 minus 9 cannot do it. I'm going to go next door to this 1 and borrow it, turning this 1 into a 0. 18 minus 9 is 9. 0 minus 4, I can't do it, so I'm going to go to this 1 and I'm going to borrow from it, making it a 0. 10 minus 4 is 6. 0 minus 0 is 0. This 8 cannot subtract 9 from it, so you're going to borrow 1 from this one, making it a 0. 18 minus 9 is 9, and that 0 you don't have to worry about anymore. As you borrow these 1s, you might end up with 0s, and that's completely fine. The only issue will be is that unless the number underneath it's a 1, you know you're going to have to borrow to make that number bigger. Alright, if we're going to compare the two numbers that you see on the screen, do not forget that the alligator eats the bigger number. So I have 45,000, 54,000. 5 is larger than 4. Alligator, nom nom nom, is going to eat the 54,000. 234,500, 245,300. If I compare the 100,000s place, they're the same. But if I compare the 10,000s place, the 4 is larger. Alligator, once again, is going to eat the larger number. Nom nom nom. We're going to balance some equations on this next page. We're not trying to find the answer. We're simply trying to modify these numbers so we can have an equation that would get the same answer. So in order to do that, I have to draw lines between my firsts and my seconds. What do I mean by that? On this half of the equation, right, there's the equal sign, so this is the left half. This is number 1, this is number 2. On the right half of the equation, I have number 1 and number 2, although number 2 is missing. So I'm going to connect the first number to the first number and the second number to the second number. I like to draw the arrows second because I'm going to make sure the arrows go to the side of the equation that has the blank. So if the blank is on the right side of the equal sign, then the arrows are going to be on the right side. If one of these was blank, then I would draw arrows on the left side. Okay? Now ask yourself the question, how does this number become this number? Well, it looks like you're going to need to add 1 to make this number turn into this number. And since this is a subtraction problem, we're going to use the give-give rule. So if I give to one number, I have to give the same amount to the next number. 899 plus 1 is 900. Once again, down here, I'm going to connect the first number to the first number and the second number to the second number. The arrows go on the side that has the blank, which here is the right side. Ask yourself the question, how does 86,387 become 86,400? Well, it looks like you need to add, what is that, 13? And because this is an addition problem, which is not what we had up here, it's going to be a different strategy. On subtraction problems, you can give the give, or the take. Okay? But if you're doing an addition problem, you have to do give and take. So if one of them's add, the other one's subtract. If one of them is subtract, the other is add. So if I'm adding 13, I have to subtract 13 from the second number. And that becomes 33,113. So remember that. On subtraction problems, you can use give, or take. They have to match. If you add one, you add one. If you subtract one, you subtract one. But anytime you have an addition problem, they have to be opposites. If one is add, the other is subtract. The same amount, okay? There are a couple mistakes in here. Well, not mistakes. There are some boxes missing. Let's see what we can do. 5 plus 7 is 12. Carry the 1. Looks like they carried the 1. This 5 plus 1 plus 6 is 12. Carry the 1. 1 plus 1 plus 5 is 7. 2 plus 5 is 7. 4 plus 8 is 12. Now, this subtraction looks pretty rough, but let's see what happens. This was a 0 minus a 6. But I can't take 0 and subtract 6, so it looks like they borrowed from the 2 to make this a 10. Okay? Check your work. 10 minus 6 is 4, so that's good. Looks like they did some more borrowing and they ended up with an 11 up here. 11 minus 9 is 2. Looks like they did the rest of this without us, and then they ended up over here. This was a 10 plus 7 10 plus 7 is 13, carry the 1. And then 1 Oh, excuse me, so that's subtraction. 10 minus 7 is 3. Ha ha ha, this is not addition. 10 minus 7 is 3, that one's fine. But when they borrowed from this 4, it became a 3. 3 plus 2 is 5. Sorry, my brain went into addition mode for a second. 3 minus 2, I'm still in addition mode. 3 minus 2 is 1. I'm glad my daughter's here to check my math. Last but not least, Bill and Cindy ran a race. Bill ran this many meters, Cindy ran this many meters. How much farther did Cindy run than Bill? And it wants you to show your work. A lot of people might simply stack and subtract. Let's do it. 13,435 minus 10,976. I am going to spend a minute giving you possibly 3 different ways to work this problem. If I end up doing the one that you like the most, great! 5 minus 6 can't do it. So I'm going to go over to this 3. I'm going to borrow a 1 from it, making it a 2. 15 minus 6 is 9. 2 minus 7 can't do it. So I'm going to go next door and borrow from that 4. 12 minus 7 is 5. 3 minus 9, I can't do it. So I'm going to go next door and borrow from this 3, making it a 2. 13 minus 9 is 4. 2 minus 0, I can do that. 1 minus 1, I can do that. So the answer is 2,459 meters. What if I did the same thing, but I just altered it just a little bit? 13,435 minus 10,976. Well, I really like it when the bigger numbers are on top and the smaller numbers are on bottom, so I don't have to borrow from all the numbers. So what I'm going to do is I'm going to add, let's say 24, and then add 24. Okay, if I add 24 to this number, I get, an even 11,000. And if I add 24 to this number, I get 13,459. And you could always, if you didn't want to make mistakes, you could always try to avoid doing that in your head. Now let's subtract. 9 minus 0, 9. 5 minus 0, 5. 4 minus 0, 4. 3 minus 1, 2. 1 minus 1, nothing. And you'll notice that I got the exact same number, and I did not have to borrow anything because I made this bottom number a little friendlier with zeros. It's way easier to subtract zeros than to try to subtract larger numbers. Larger numbers on bottom means you have to go next door to borrow from a neighbor. Finally, to wrap this up, let's just do a quick number line. Some people might find the standard algorithm to be just a little bit tricky for them, and they might want to use a number line to maybe start their work or check their work. Either is fine. I'm going to put this shorter number over here, 10,976, and then over here I'm going to put the larger number, 13,435. If I go up to the nearest thousand, which would be 11,000, I'm going to have to go up. Ooh, that's a bad arc right there. I'm going to have to go up 25. Okay. Oh, that's a 76. 10,900. I was wondering why that number seemed weird. So that should be a 24. Okay. And then if I want to go back to 13,000, I'm just going to remove this 435. And then to get from 11,000 to 13,000, well, I would probably add 2,000. Yeah? And then all I need to do is combine these numbers, and I should get the same answer. 2,000, 435, 24. Add them down. What do I get? 0 plus 5 plus 4 is 9. 0 plus 3 plus 2 is 5. Nothing plus 4 is 4. 2 plus nothing is 2. 2,459, which is the answer that we got using both methods before. Why am I giving you so many options? Because getting the right answer is your goal. Sometimes your standard algorithm could be messier than you want it to be, and you might want to use a give-give strategy. If it seems like you are unsure of either, you could hop into a number line to double check your work. At the end of the day, if one of these didn't feel great, double checking it with another strategy could be the difference between getting the right answer or having an incorrect one. As usual, if you have questions, please ask a math wizard. Teachers love it when you come to them and ask them for help. Otherwise, good luck on your unit test.